All right, let's talk about two of the most powerful and, let's be honest, sometimes confusing buttons on your calculator. I'm talking about logarithms. But stick with me, because by the end of this, you're going to be using them like an absolute pro.
So you've seen them, right? Just staring back at you from your calculator keypad. The LOG button and the LN button. They seem straightforward enough. But then, what happens when your algebra homework throws you a total curveball, asking for something like log base 7 or log base 52? How in the world are you supposed to solve that?
Okay, let's break this down. Why do log and ln get their very own dedicated buttons? Well, it's pretty simple. They're basically the celebrities of the logarithm world. They pop up so often in science, engineering, and math that, yeah, they get special treatment.
Now take a look at this. This table lays out the key differences perfectly. When you see log written out, or when you press that log button, you're dealing with the common log, and that always means base 10. ln, on the other hand, well, that stands for the natural log. That one uses a really special number called e as its base, which is roughly 2.718.
All right, first up, the common log. This is your absolute go-to for anything involving powers of 10, and you'll be surprised at just how simple it is to use.
Let's say we need to find the log of 500. It is literally as easy as it looks on the screen. You just press the LOG button, punch in 500, and hit enter. That's it. Your calculator does all the hard work.
And boom, there's our answer, about 2.699. Now, let's do a quick little gut check to see if that makes sense. We know that 10 squared is 100, and 10 cubed is 1,000. So since our number, 500, is right there between 100 and 1,000, it makes total sense that our answer is between 2 and 3. Perfect.
Now for our second celebrity log. This is the natural log, and it is all about that unique, kind of weird mathematical constant, e. It might feel a bit more abstract than good old base 10, but trust me, it's incredibly important, especially once you get into things like calculus.
So what is the natural log, really? Well, that ln button on your calculator stands for a logarithm with a base of e. And a little fun fact for you, ln actually comes from its Latin name, Logarithmus Naturalis. It's just asking a simple question. E raised to what power gives us our number x?
And here's the best part. The process is exactly the same as it was for the common log. If you want to find the natural log of 10, you just press the ln button, type in 10, and hit enter. Again, the calculator does all the heavy lifting for us.
And we get an answer of about 2.303. So what does that number even mean? It's just the power you would need to raise e to in order to get the number 10. It's as simple as that.
Okay, so we've mastered the two dedicated buttons. But that brings us right back to our original question, what about log base 7? Well, this is where the magic happens. We are about to unlock the master key that can solve any logarithm you can think of.
And here it is, the change of base formula. Honestly, you should think of this as a universal translator for logs. It basically says that the log of some number x with any base b is just the common log of x divided by the common log of b. And you know what the best part is? It works the exact same way if you want to use natural logs instead. It's totally flexible. Okay, let's put this thing to the test with our original problem, finding the log base 7 of 50. Using the formula, we just rewrite this as log of 50 divided by log of 7. We can punch each of those into our calculator, get the two values, and then just do the final division. And that gives us our final answer, approximately 2.012. Now, let's quickly check our work. Is 7 raised to the power of 2.012 roughly equal to 50? Go ahead, punch it in your calculator. It is. See, we just solved for a log base that isn't even on the keypad. How cool is that?
Now, this formula is incredibly powerful, but it's also really easy to make one simple mistake. So let's look at this single most common trap that students fall into, just to make sure you can avoid it.
Okay, look really closely at this slide. The number one mistake, and I mean number one, is shown there in that box on the right. It's getting the fraction upside down. You have to remember, the original number, what we call the argument, that's the x in our formula, always goes on top. The original base, b, goes on the bottom. So let's commit these rules to memory. The most important one is a simple little trick to remember. Base goes on the bottom. Just remember that base goes on the bottom of the fraction. And like the slide reminds us, never forget that log and ln are totally different functions. As you can see from the example, log of 10 is 1, but the natural log of 10 is a completely different number.
So why do we even learn this stuff?
I mean, is it just for a math test? Not even close. Logarithms are literally everywhere, describing some of the most fundamental things in our world, from what's happening inside a chemistry lab to the middle of a concert hall. At their heart, logarithms are the language we use to measure things that have a huge range of values. I mean, think about the pH scale for acidity, the Richter scale for earthquakes, or the decibel scale for sound. All of those, they're logarithmic scales. They let us take these enormous ranges and just talk about them in a simple, manageable way. And here's a final, really interesting distinction you might notice in your other classes. Scientists, especially in fields that use a lot of calculus, they often prefer the natural log. Why? Because the special properties of E make a ton of their calculations way simpler. Engineers, though, they often prefer the common log, base 10, because it aligns so perfectly with our standard number system and all those measurement scales. So, there you have it. You've officially unlocked the full power of your calculator's log functions. You now have the master key to translate any log problem into a simple calculation you can do in seconds. The only question left is, what exponential equations are you gonna conquer next?